Guys, welcome to our channel of Sciences and Mathematics. Today we are going to look at a concept in volumetric analysis, and that's going to be the concept of dilution. Dilution is one of the processes that we can use to achieve a concentration of a solution of our desire whenever we are trying to perform a chemical reaction. Now this is very important because concentration, when we are trying to look at the concept of chemical kinetics, is one of the factors that play a role in trying to determine how a reaction is going to take place. So for that case, for today, we're going to use a sample question on the board, trying to find out how we can be able to achieve or maybe perform the process of dilution of a solution, having been given a stock solution or a solution of a specific unknown concentration. So for that case, thank you and welcome. So as I've said today, our discussion is going to be centered around our topic in volumetric analysis, and that is going to be the topic of dilution. Now, basically, as I've said, dilution entails preparation of a less concentrated solution from a more concentrated one. So this or maybe when we talk about the aspect of our concentration, come across this specific term in one of our videos or some of our videos that it playing a very important role in trying to achieve some or specific products when we are trying to do a chemical reaction. Now in this sense, we're going to look at concentration as an aspect that we can be able to use or manipulate in order to get maybe products or solutions of desired concentration or maybe strength in order to perform some of the chemical reactions. Now basically this is going to be a general procedure, and there are some of the factors that we're going to consider whenever we're trying to perform these concepts of dilution. And I'm going to list some of them on the board. Now, when we are trying to do maybe a purchase of a specific chemical, now commercially they come with specific labels that bears the molecular weight. So the inscription on these specific containers may be commercial containers that bear chemicals, or maybe contain chemicals, come with some of the inscriptions that consist information on chemicals, and one of them is the molecular weight. The next one is the percentage purity of that specific product, percentage purity, and then maybe you can be able to be given information on the density of that specific product. So therefore, being given this information, this one is essential and it can assist us in trying to prepare maybe a solution of a particular concentration from this concentrated one that we refer to as a stock solution. So the solution, the product that we have already purchased, which has got this specific specifications that are listed on the board, then we refer that one to as a stock solution. For example, if a container comes with maybe an acid or a base which has got some labels on its maybe on its container, this will guide us to do what we call I've specifically mentioned about this term because of this a video we have discussed on the concept of standardization. And as I've said, maybe if a container comes with a specific maybe product with labels, this will guide us on their standardization or trying to prepare maybe solutions of different concentrations. For example, if a container which has got the product of sulfuric acid, and on its maybe on its package there's an inscription for specific characteristics of that particular product, maybe the molecular weight for this, of course we know this one is going to be 98, but to that degree of accuracy, 0.07, and then maybe its percentage purity is given as 99.07. This is percent, and then in this sulfuric acid maybe has been given a density, or this is raw, a density of 1.836 grams per milliliter. And this is the stock solution maybe that we have purchased from the market. Now from this stock solution, we can be able to determine the molarity using the basic concepts that we have learned from the mole concept. We can be able to find molarity of this specific solution. Now we're going to use this information in order to try and determine the aspect that I've talked about, whereby we know that molarity is equals moles, or basically this moles per liter of a solution. So generally we can define molarity as moles per liter of a solution. And when we're trying to look at volumes, this one has been indicated in millimeters. We know that 1 millimeter is equivalent to 1 centimeter cubed, and 1 decimeter cubed is equivalent to 1 liter, which is equivalent to 1,000 centimeter cubed. So whenever we're given any of these specific units, we can be able to do an appropriate conversion in order to find the quantity that we are being asked to. So in this case, basically I'm going to restrict myself to the aspect of centimeter cubed, so that we use it as a general unit for volume in our discussion. So the density which we have been given here is 1.836 grams. Basically this one is contained in 1 centimeter cubed of this specific product, which is sulfuric acid. So therefore we can have a relationship of trying to find out what specific quantity will be contained in a liter of this specific solution. Now that we have defined the molarity as a number of moles, we can be able to do a relationship between the mass and moles by trying to figure out what is the mass in grams of this specific acid in 1,000 centimeter cube. So in order for us to find that, we're going to do a cross multiplication for these specific quantities and try to find out what is the quantity of that specific acid. So therefore X is going to represent 1,836 grams in a liter of that specific solution. But we have been given from the information in this particular product that the purity is 99.07%. And in this case, maybe this was 99. From my sample question, I just created this one. Percentage purity to 0.99%. So therefore we can be able to find the actual mass of this specific sulfuric acid in this particular product by trying to find this percentage, the actual percentage, or maybe the actual mass, using this concept of a percentage purity in that liter over that specific solution. So this is going to be 1799.9.09 grams of sulfuric acid in that specific liter. So this is the mass of that specific product in a liter. So I'm just going to do away with it. Now that we have just used these three, maybe I'm going to mention them in case we come across them, but I'm just going to do away with them so that we can have space to do our work. So we can be able to find molarity of this specific acid having been given that information, whereby molarity is grams per liter divided by the molecular mass, the molar mass of that product. So therefore, the molarity for this acid can be found by dividing grams per liter, which we have already found here. So 1799.09 divided by the molar mass for sulfuric acid is H2SO4. So this is 2. Okay, for hydrogen it is 2 times 1 plus sulfur. This is 1 times 32 plus this oxygen 16 times 4. But we had been given molar mass from the inscription on the product, which was 90. Basically, this is going to give us 98, but for the sake of accuracy, we had been given that molar mass to be 98.07 grams. So basically, we have to restrict ourselves to that one. So this is in case you haven't been given the molar mass for that kind of a product, but in case it's provided, we restrict ourselves to the particular maybe figure which has been provided. So this one is going to give us what we call the molarity. So therefore, this is going to be, I'll just do away with this grams per liter. So therefore the unit is going to remain per liter, so therefore, which is the molarity. So molarity is going to be 18.34 molar sulfuric acid. So from our discussion in this case, we're going to see that we can be able to derive the molarity or the concentration of that stock solution that we have been provided using the information on the inscription box. So from that case, if we need a particular volume from that specific solution, then it will be easier for us in order to find what quantity we need. Now, in order for us to tackle our question, I'm going to give a general representation for trying to find molarity given specific concentration for either the stock or the dilute solution that we have talked about. So I will just do away with this. So suppose we are given either some of this information I've listed maybe on the label of a container of a specific product, and we can be able to use the concept that I've used in order to find the molarity. Now, what if we are given maybe the quantities which we have already been discussing, and whatever you are needed to find is maybe one of the quantities. There's a relationship that exists between the number of moles of a stock solution and dilute solution, whereby the number of moles of a stock solution equals number of moles, sorry for that, of dilute solution. So this statement can as well be represented in another format. Whereby we will find that the product of molarity of a stock solution and volume of the stock solution is equals molarity of the dilute solution. I'm just using those initials to represent stock for dilute, stock and dilute, times the volume of the dilute solution. So this formula, having been given either of maybe the three of the quantities, we can be able to find one by just making it subject to that formula. So using initials, I can be able to represent this one as mass of the molarity of the stock solution times volume of the stock solution equals molarity of the dilute solution times volume of the dilute solution. Or basically, in some other texts, you can find it being represented as molarity of the initial solution times volume of the initial solution equals molarity of the final solution times volume of the final solution. So basically, from our question, we can be able to look at it and try to find a relationship between either of these two formula, and try to see which one we can be able to use to find our answer to that. So basically, the question says determine the volume of 18.35 molar sulfuric acid required to prepare 500 centimeter cubed of 0.5 sulfuric acid. So basically, from this, determine the volume of, we have been given the molarity of the solution as 18.35. So this is M initial times required to prepare. So determine the volume. So this V1 basically, or V initial, actually we are not been given. Required to prepare 500 centimeter cubed. So the final solution should be 500 centimeter cubed. So that is V final. of 0.5 molar. So therefore, we've been given the second concentration as 0.5. Basically, whatever that is missing is this initial volume that is required to prepare the volume on the other side. So therefore, we're going to make I the subject of the formula, VI, volume initial, the subject of the formula. And this is going to be 0.5 times 500 all over 18.35. Now basically, because we have been provided for volume in centimeter cubed, the initial volume as well is going to be in centimeter cubed. And this one of course requires to maybe change it into liters, or maybe use the standard unit. But in any case, I said that we are going to restrict ourselves to the centimeter cubed. Now this one will give us 0.14 liters, basically, which we multiply by 1,000 for a centimeter cubed, which is going to be 14 centimeter cubed of that specific concentration of an acid, which is 18.35 required to make this concentration at that specific volume. So in this case, we have had a discussion for this concept of dilution. Now I felt that it is important for us to try and figure out, or maybe connect the relationship between the stock solution that we normally find on when we're just trying to purchase the product from the manufacturer. There's some of the information that we get maybe as an inscription on the containers or packages, which can assist us to maybe prepare or maybe try to determine the molarity and the concentration of that specific solution. So having been given that information, we can either be able to use it, or in any case, it's the concept of problem solving and we've been given a question of such kind of a nature, then we can be able to use either option 1 or 2 for finding the relationship between molarity and volume for the stock solution and dilute solution. So this basically is going to assist us much in our lab work, especially when we need to prepare solutions of different concentrations in order to perform experiments, or maybe in trying to do research on a specific topic. So for that case, I hope that the concept of dilution has been understood, and we are going to do other complementary videos on maybe problems in order to supplement on what we have discussed, and that is going to assist us maybe in trying to improve our skills and trying to do maybe some of the problems regarding to dilution. So for that case, that is it for today. Bye guys, God bless.